Hello everyone. Two identical elastic cords of negligible relaxed lengths. So when they are relaxed, their lengths can be neglected. So whatever length is shown in the diagram is actually the length in elongation. So they are tied at one of their ends to fixed nails A and B that are equidistant from the origin. Origin is O. The other ends of the strings are tied to a small ball. To hold the ball in equilibrium at the point P, that is 4,3 meters, point P's coordinate is given 4 meter, 3 meter. Force of magnitude F equal to 1000 Newton is required. So assuming free space conditions, vacuum, they are placed in vacuum. That means gravity and other things can be neglected. Dielectric constant of the medium can be neglected. So we have to find the force constant of the cords. So let us solve this problem. Actually, if we solve this problem from vectors, then it will be very easy. 1 second. So let us try to solve it by the free body diagram of point P. Actually, if I say that K is the spring constant, then K will be identical for both the springs. So a force on the point P will be acting along PA, and this will be like this, and it will be K into, let us say, call this PA vector. Another force will be acting along the length PB, and this will be K times the length PB, because initial elongation is 0. And if we try to complete this parallel, there will be a parallelogram corresponding to this triangle APB. So if I complete this parallelogram, the parallelogram will look something like this. Approximately it will look like this. And since the point P is in equilibrium, because the force 1000 Newton is acting like this, then the resultant magnitude of the force is 1000 Newton. Then the resultant of the two forces, K into PA vector and K into PB vector, this must be exactly opposite to 1000 Newton. And from parallelogram law of vector addition, we can say that this will act along the diagonal. And the diagonal will be passing through the origin O. It will pass through the origin O. And if I call this point as C, then definitely PC will be twice of PO. So resultant we can write as the magnitude of K into PA vector and plus PB vector. We can take K common. This magnitude must be equal to 1000 Newton. And because this resultant must act along PC, so we can write this as K into PC vector. Magnitude must be equal to 1000 Newton. And PC vector is exactly twice of this length PO, because it is O is the midpoint of PC. So we can write it as, if I remove the vector symbol and the mod symbol, we can write it as 2 into PO and into K. This will be equal to 1000. And because the coordinates of P is 4,5, so 4,3, sorry, 4,3, then this length will be 5 meter. This length will be 5 meter. So K into 2 into 5 will be equal to 1000. 2 into 5 is 10. So K will be 100 Newton per meter. So that is the answer. So if you do it by vector using this parallelogram trick, then it will be solved in 2 or 3 lines. So that is it.